Hello children, let us start with one more interesting example, again out of the textbook but within the syllabus. This is a given figure. In this figure it is given that segment EK is parallel to side AB and DB is equal to EC. Let me mark the congruent segments. Okay, this segment is congruent to this segment. This is given. And we have to prove that these two ratios are equal. Okay. So, what I usually do, I am doing it again. From the figure, let me separate out some part, and that I have done. Triangle ABC and segment EK I have separated. And if you have practiced enough, you know that if this side is parallel to this side, immediately the two triangles in this figure are similar to each other. We should always start with vertex, okay? Common vertex. So CEK is similar to CAB. Without any thinking, you should be able to say that yes, these triangles are similar. How to prove? That also should run down in your blood. Okay? Let us see. This segment is parallel to this segment. We have written. Okay, this is actually given to us. And therefore, this angle will be congruent to this angle. This angle will be congruent to this angle. Corresponding angles we have written. CAB, angle CAB is congruent to CEK. Okay, and angle CBA is congruent to CK. Written. And if these two pairs of angles are congruent, obviously the triangles will be similar by AA test. Okay, so we have written in these two triangles, these two pairs are congruent. From where did you get this? From 1. From equation 1. Okay, and therefore these two triangles CAB and CEK are similar for the same correspondence. Okay. How to write the correspondence, that we have seen in enough number of examples in the syllabus. Okay. Therefore, now from this similarity of two triangles, we get two conclusions. Corresponding angles are congruent and corresponding sides are proportional. But when we say corresponding sides are proportional, we mean the ratios are equal. The ratios of corresponding sides are equal. Now, I get three ratios equal, but again, if you use the common sense will tell you that instead of writing all three ratios equal, why not write only those ratios which are required in the result, in the equation which we want to establish. Okay, and therefore, what we have done, here I wanted AC, and from here I am getting AC. The corresponding side of AC will be EC. So the ratio of AC and EC will be equal to AB upon EK. AB upon EK. The question is, why again I took AB? Because AB is also required in the result. Okay. So then interchanging AB and EC, which we can do by alternando. Okay, you get this AB will come here, EC will go this side. AC upon AB is equal to EC upon EK. I have given that as equation number 2, and which we have done by using alternando. Alright, so by separating one triangle ABC and EK, we have reached to the left hand side of the required result. Now, again I am going to use segment EK. Okay, segment EK is parallel to DB. So now I am separating triangle BDF. Okay, triangle BDF and segment EK, which we have drawn that side. BDF and segment EK. This segment is parallel to this, that is already given. So this figure and that figure, are they two different figures? Yes, they are, but the logic is same. Here also these two angles are congruent. Here also you can say that these two angles are congruent. Okay, then you will say that
this angle is congruent to this angle.
same. Whatever is the logic in this figure, same is the logic in the second figure, which is separated from the original figure. So I have written FDB. FDB is congruent to FEK. Okay. Then FBD is congruent to FKE. Same thing is written here, because these are corresponding angles. And we have used the same congruence of two angles, two pairs, to prove that the triangles are similar. So again, I tell you that there are certain hidden informations, there are certain hidden results which you have to use. As soon as you say a triangle in which one segment is drawn parallel to one side, immediately the triangles are similar. FEK will be similar to FDB. Same thing we have written. FDB is similar to FEK. Again, the triangles are similar. We get two conclusions, that the corresponding angles are congruent and the corresponding sides are proportional. But the question is, we are interested in establishing the relation pertaining to sides of the triangle. So I am going to use that the corresponding sides are proportional. Okay. So again, that may again lead to different things, different conclusions. Which sides shall I take? I should take those which are required in the result. So here you have DF. Do I have? Yes, I have. So DF upon EF I wrote is equal to, what else I need? EF. Do you have? Yes, EF we have here. So DB upon EK. DB upon EK. EK is the linking segment. EK is the linking segments. So this segment should be used in both of the triangles. So I wrote DB upon EK, but we are given that DB and CE, they are equal. So DB is equal to EC. This is given. So in place of DB, if I put EC, this equation converts to DF upon EF is equal to EC upon EK. Any doubt? So simple it is. Okay. DB I have replaced by its equivalent EC. So you get EC upon EK. Now let us observe equation number 2 and equation number 4. Observe. What is the right hand side of equation 2? EC upon EK. What is the right hand side of equation number 4? EC upon EK. So the right hand sides are same. That means the left hand sides are also same. So AC upon CB, this is equal to DF upon EF. AC upon CB is equal to DF upon EF, and that is what is the required result. Okay. So we have seen a previous example also. What I realize that the previous example and this example are mostly based on similar triangles, similarity of triangles, and having more or less the same logic. Okay, but definitely without practice getting the result will be difficult. So if you come across a new problem directly in the examination, I know that you will struggle. But who will survive? Who will get full marks in this situation? Those children who have the practice of writing many examples, solving unseen examples. Okay, so this is one of them. Thank you, children.